In the previous section, we finished reviewing some of the new features in C# 8. In this one, we will handle errors and work with asynchronous concepts in C#. Let's begin with an overview of delegates and events. Before we can dive further in to delegates and events, let's set up an example. I'm going to create a new class called car, simulating, well, of course, a car. Let's add some properties describing a car. A car has a make and a model, but most importantly for our example, a car has a current speed when it's moving, or if it's stopped, current speed is set to 0. I'm going to set its setter to protected so that only this class can manipulate the current speed directly. Classes outside of the car class should have access to the current speed, but through the accelerate and brake methods. Just like a normal car, you can't on the fly set the current speed to something. You need to access the current speed via a public interface with the accelerator and the brake. So there you go. We can accelerate by 5 km per hour each time or brake by 5. This is a very simple, simplistic actually, car class. Let's go ahead and define our first delegate. A delegate describes a function that can be used as a callback to catch and watch for an event. So we set up the delegate like this. Don't forget the public accessor and the delegate keyword. And now we can use this car speed changed delegate to define a series of functions that can be used to watch for events happening on the current speed. So if someone wants to watch for changes in the current speed, they have to register with this delegate, this car speed change delegate, and they need to provide a callback that is and looks like the car speed change delegate we defined on line 7. Now let's go back to the accelerate method and we can do something like this. We can invoke the speed change delegate. There are several ways of doing so. If we have an async delegate, we need to use the begin invoke method, but if we have a non-async delegate like this one, we can use the invoke method, passing in the previous speed and the current speed. But because this speed changed delegate may be empty, perhaps there are cases in which nobody registers for watching the current speed. In those cases, we don't want to invoke the speed changed event. Therefore, we need to always check if the speed changed is other than null. As an exercise, you could apply the same thing to the brake method or extract this into an interface that can be used or function that is reusable so we can remain dry. For now, let's go back to the main method and set the car up. So we initialize a car, use a fake make and model, and by default the current speed is going to be 0. So let me set this up to public so we can access it. So now we can go here, find the speed changed delegate and register to it. Now how do we register to this? We can begin by defining a function that looks exactly like the delegate we have declared in the car class. So we need a function that returns void. The return type is also important. It must match the return type of the delegate. And we need 2 arguments, no more, no less, 2 integers for the previous speed and the current speed. And then we can go ahead and log something to the console every time the speed changes. So we can say current speed went from, so the car went from going to previous speed, kilometers per hour, to current speed, something as simple as that. Remember, as of now, only the accelerate method has a watcher and triggers the current speed changed event. And we can register our method to the delegate like this. We can then go ahead and accelerate, and perhaps we can then wait a few seconds until we can accelerate again. We can do so by using the thread sleep events followed by the time in milliseconds that we want to wait for. So in this case, let's just say that we want to wait for 1000 milliseconds. If you check at the signature, you're going to see that we need an integer describing the time in milliseconds that we need to sleep. We will look more into threads in a later video in this section. For now, let's just accelerate a second time and run the application so that we can see if our delegate prints the correct string, the correct notification, once the car goes from 0 to 5 and then from 5 to 10. Perfect. Now, let's go back to the car class and let's see how we can change this and replace it with an event, because right now we can only have one watcher. It's easier to have multiple watchers, multiple observers of the current speed if we introduce events. How do events work? Okay, we need to have an event handler. The event handler is a generic delegate, actually. You can have any delegate with an event, but most of the time when we want to define an event, we use an event handler. And the event arguments, which is the first type argument that we need to pass to the event handler, should derive from the event arguments base class. And in here, we can place any arguments that the event handler needs to supply, because this is a generic event handler. So a generic event handler can have a variable number of arguments. So we can't say that we need 2 arguments. We need to convert them into an object, an instance of this class. We can set both of the setters to private so that they're kind of constant. And we can only supply some values for this properties, the prev and current speed, via the constructor. Of course, there are multiple ways of doing so. We could define them as read-only, but let's stick with something simple, because right now we want to focus on what the event and the event handler can do for us. So now that we have a class representing the arguments of the event, we can pass it as the only type argument to the event handler delegate and create this onCarSpeedChanged event. This is a nice convention to prefix your events with on to describe that they're actually events. Now that we no longer have the speed change delegate, we can come back here, have the same check, and then we can, again, with the same way, invoke the onCarSpeedChanged event. The first argument describes the sender who is throwing the event, in this case, this class. This is why we use the this keyword. The second argument is an instance of the CarSpeedChanged event arguments that we defined to the top of this file, and we instantiate that with the previous and current speed. Now back to the main method, we can use the plus equals operator to register an event handler for this event. But now our event handler has changed because we no longer have that same format. But hopefully Visual Studio can, with 2 clicks to the tab key, can generate a handler for us, and we can even rename it with this refactor functionality. Great feature by Visual Studio. So one more time, plus equals, and then hit tab on your keyboard twice, and we have our car speed watcher 1. And I'm calling it 1 using that suffix because we're going to have multiple car speed watchers later. So the watcher 1 is reporting that the car is currently going with a current speed of e.current_speed. E is an instance of the car speed changed event arguments. And a second watcher perhaps can even report the previous speed, or generally something different. So we have a second watcher. This is actually a very easy way of implementing the observer pattern, along with some event-driven principles. So we have a second watcher saying that car went from, and then followed by the previous speed, and then we can add the current speed. Perfect. So now, with the event keyword, we can have multiple watchers watching for the speed, while also maintaining an easier interface and a good naming convention for our events.